Every night, the moon is a little farther away than it was the night before. Not by much, not enough to see, or even to measure without sensitive instruments. But it is happening, drifting outward by about a few centimeters per year, a slow retreat that has been going on for as long as the Earth-Moon system has existed. The cause is not mysterious. It is tides, the same tides that push and pull at every coastline on the planet, quietly rearranging the architecture of the solar system one wave at a time. Here is the mechanism. The moon's gravity pulls on Earth's oceans, stretching the water into a bulge on the side facing the moon and another bulge on the far side. If Earth stood still, those bulges would line up perfectly with the moon, directly beneath it. But Earth does not stand still. It spins on its axis much faster than the moon crawls around its orbit, so the planet's rotation drags the tidal bulges forward, ahead of the moon's position, before gravity can snap them back into line. Those slightly misplaced bulges still have mass, and mass still has gravity. Sitting just ahead of the moon, their pull tugs the moon forward in its orbit, like a hand giving a small push to something already moving. That forward tug adds energy to the moon's motion, and an object gaining orbital energy does not speed up in place. It climbs. The moon rises into a slightly wider orbit, trading a small forward shove for a larger, slower loop around Earth. Nothing in this exchange is free. While the bulges are busy giving the moon its push, the friction of dragging enormous volumes of ocean water across the sea floor acts like a brake on Earth's spin. Earth loses rotational energy even as the moon gains orbital energy. The two effects are two sides of a single transaction, gravity moving momentum from one body to the other, patiently, tide after tide, for as long as oceans have existed. The result shows up in Earth's own calendar. Because the planet has been slowing down, its days used to be shorter. Hundreds of millions of years ago, a full day, one complete spin of the Earth, may have been closer to 22 hours rather than 24. Sunrises came faster, and more of them fit into a single year, even though the year itself, one trip around the sun, stayed the same length. In that ancient sky, the moon would have looked noticeably larger too, simply because it was sitting closer, filling more of the view above whatever coastline or ocean happened to lie below it. This is not just an astronomical curiosity happening far overhead. It reaches down into the history of life itself. Tides shape coastlines and ecosystems, carving out the rhythmic, in-between zones where water and land constantly trade places. Some scientists think environments like these, repeatedly flooded and drained by the pull of the moon, were part of the setting where early life on Earth first took hold. The rise and fall of the tides, over and over across enormous stretches of time, kept those borderland environments in constant, gentle motion. The moon's influence does not stop at the waterline either. Its steady gravitational presence helps stabilize the tilt of Earth's axis, keeping it from wobbling wildly over long stretches of time. That stability is a large part of why Earth's seasons arrive with reasonable regularity instead of swinging unpredictably from one extreme to another. A planet without a large companion moon might tilt and tumble far more erratically, scrambling the very idea of a dependable spring or winter. So the moon is not just a nightlight hanging in the dark. It is one half of a slow gravitational exchange that is quietly reshaping both worlds at once. This slow separation is not a breakup. It is closer to a very long, very patient conversation carried out entirely in gravity. Every tide that rolls onto a beach is a tiny transaction between two worlds. Earth quietly gives up a sliver of its spin. The moon quietly banks a sliver more distance and a slightly wider orbit to carry it in. The relationship is ancient, it is gentle, and it is still unfolding tonight, above whatever rooftop or coastline happens to be under your sky. Look up, and you are watching a companion that has been saying a slow goodbye since long before there was anyone here to notice, and that will keep saying it long after we are gone. The moon is not leaving quickly. It is leaving the way tides move, patiently, inevitably, 1 centimeter at a time, bound to Earth by the very forces that are slowly pulling it away. Follow for more random things you may not know.